Welcome, everybody. This is Julian from AWS, and I'm super happy to be back with a new webinar. And today we're going to talk about Amazon SageMaker Studio, one of the most exciting services launched at AWS reInvent just a few months ago. So before we dive into the service itself, let's just look at what it means to build machine learning workflows today. And unfortunately, it is a pretty difficult task. You have to go through a number of different steps, and there are so many different tools you could use for each of them. And you need to get everything right. Everything needs to line up perfectly if you want to build a successful model and deploy it. So of course, first you need to prepare your data set. You need to collect data, you need to annotate and clean and transform data and get your training set ready. And then once you have that, you can start experimenting. You can start trying out different algorithms. And there are quite a few, right? From statistical machine learning to deep learning to even more exotic techniques. There are plenty of things you could try. So you need to have an environment for experimentation and basically a sandbox you can use. And then once you start to figure out which algo is going to work for you, of course, you need to train, you need to try out different data set combinations, different parameter combinations, and that requires a bunch of infrastructure, right? And no one really wants to manage that, but hey, you have to do it, right? You have to power those training jobs, and you need to debug them because sometimes they don't go the way they're supposed to go, and this isn't an easy thing, understanding what's really happening during the training process. And then you need to tune them. You need to extract every bit of accuracy from that training job in order to get the best possible answers to your for your predictions and the best business outcome. And of course, over the time of the project, you're gonna end up training hundreds, maybe thousands of jobs, and it's not easy to remember what did you do last week. You know, where's that high performance model you tried, and you know, what were the parameters for it, and what data set did you train it on? So managing that stuff becomes a project in itself, and a lot of customers actually build tooling around that. And once you have a model that you really like, then I think comes the hardest part, which is deploying that model in production, bringing it in your production environment where it can start predicting from samples that your business apps send to it. And you need to monitor that and make sure your model is performing the right way. Make sure you can actually reproduce in the production environment the performance and the accuracy that you saw in your dev and test environments. And of course, as your app becomes successful, you need to scale your prediction infrastructure, and you need to manage everything from high availability to security and all that good stuff. So as you can see, although people tend to focus a lot on algorithms and data science and neural networks, there is quite a lot of stuff that needs to be done if you want your machine learning project to be successful. And so, you know, this stands in the way of achieving your the expected outcome, which is why we, a couple of years ago, we launched a service called Amazon SageMaker. And at AWS reInvent just a few months ago, we expanded on SageMaker and we added a bunch of capabilities. And I'll demo some of them in just a few minutes. So I guess we still see the same workflow, you know, preparing, building, training, tuning, deploying, managing. This is still true. Those problems are still there. But we added a whole bunch of capabilities to let you basically go from experimentation all the way to production using the same modular service and the same modular APIs, trying to really to give you an end-to-end solution with capabilities like SageMaker Debugger to debug your models, or SageMaker Experiments to help you track your thousands or tens of thousands of different models, SageMaker Model Monitor to help you check your models in production and detect unwanted problems like data drift or missing features, etc., and a whole, again, a whole collection of additional features. So, and on top of this, we launched SageMaker Studio, which is a web-based IDE for machine learning, where, of course, you can still run your notebooks and you can still work in the usual way. But we're also plugging, so to speak, all those different capabilities into SageMaker Studio so that you can have that single pane of glass where you just switch from one tab to the next and run your notebooks and jump from debugging to monitoring, etc., etc. Okay, so well, let's just look at it, right? I mean, let's just run quickly through the main features of SageMaker Studio. And I want to call out parts of SageMaker Studio are still in preview. So you can absolutely go to the AWS console today. Just make sure you go to the Ohio region, okay, US East 2, which is where Studio is available. Just go to the SageMaker console and you will see the link to SageMaker Studio. There is a simple setup procedure, just very simple steps to get access to that, and you can start using it in just a few minutes. Okay, and so what you'll find in Studio is, of course, notebooks, but you don't have to create notebook instances anymore. If you've used SageMaker before, you probably know about notebook instances, fully managed instances that come pre-installed with Jupyter environments and Conda environments and all your favorite machine learning and deep learning libraries. These are still there. You can still use those if you're comfortable with that. But one of the main new things in Studio is the ability to just open Studio and get access to, let's call them serverless notebooks. Okay, you don't have to start instances any longer. Okay. Fully integrated in Studio is experiment management. Okay, so that's this SageMaker experiments capability, and we'll look at it. You can also run AutoML. You can automatically create a machine learning model, and this is actually a no-code experience, and I'll show you how to do that. And you have quality and productivity capabilities. Okay, so the model debugger is integrated in SageMaker, so you can easily look at any issue that's happening. Model monitor is also integrated into SageMaker Studio, so you can just quickly and easily enable data monitoring on an endpoint that has been already deployed, etc., etc. Okay, so again, that's the philosophy of Studio. It's an IDE. It's still based on notebooks, and it's like the high-level IDE on top of all those new capabilities. Okay, I just want to say you can absolutely still use notebook instances, or you can use your own local Jupyter notebooks, and you can use the experiments SDK, and you can use the monitoring SDK, etc. But we're trying to make it simple with SageMaker Studio. All right, enough talk. Let's let's go and look at a demo. So here we are. So this is what you get if, like I said, you go to the US East 2 region, okay, the Ohio region, go to the SageMaker console, and you will see that link to Studio. Take care of that setup procedure, just follow instructions, pretty simple, and you get a link, and which you can see in my browser here, and you just click on this, and it opens SageMaker Studio. Okay, and it looks very, very familiar, and we can create notebooks, and we can open terminals, etc., etc. So on the left here, I can see my files, and I already cloned a few repos with some sample notebooks, and I'll just show you some of those extra icons along the way. So let's just start looking at a notebook. Okay. So this is one of my examples. Here I'm training. I just want to show you. Let me maybe remove this. Yes, give you a little more space. This is one of my machine learning notebooks. And basically here, we're training an XGBoost model. And we're building a classification, a binary classification model on a data set for direct marketing. So it's a very simple problem. We have customer records telling us if a given customer, yes or no, has accepted a marketing offer, okay? And we want to build a classification model using that, okay? So first, of course, I start by installing a few libraries that I'm going to need, the SageMaker SDK, etc. And then I simply download my data set and extract it. And this is what it looks like. It's a CSV file, okay? And so we see a whole bunch of features here. We have employment status and marital status and some extra information. And the last column here, so to speak, tells us yes or no, did that specific customer accept the offer, okay? So of course, we don't want to look at CSV files. We want to look at something a little more pleasant. And so I use the pandas library, which I keep calling the Swiss Army knife for data science. So I'll call it like that again. And we just open that CSV file and we display the first 10 lines. Okay, and as I told you, okay, we see some, we see features and we see that label, and the column is called Y. Okay. So a lot of those say no because most people will say no to a marketing offer, but trust me, we have some yeses in there. We have a little more than 41,000 samples and we have 21 columns, so 20 features and that yes or no label, okay? And one of the interesting things about this data set is it is very unbalanced because again, a lot of people say no and very few people say yes. So we have about an 8-to-1 ratio. And that makes it difficult to build a good classifier. Okay, so that's the kind of analysis you would do. Then we do a little bit of transformation because that's part of the fun of building machine learning models, preparing data, etc., etc. So I won't go too deep into that. We'll share some links to those notebooks and you can review those, but basically we're kind of removing fields or columns that make no sense. We're kind of putting in the same bag, students, retired people, and unemployed people, because it kind of makes sense. Those would have maybe less money to spend on a marketing offer. So we create a new column called not working, and to flag that those three jobs are probably related. And we convert all the categorical variables and using a technical one-hot encoding. So basically, as you can see, we explode the job into as many columns as we have job titles. And this helps the model understand the different dimensions. Okay, so you're either a blue collar or an entrepreneur or a housemaid, etc. So this technique helps the algo understand that those are really different things, right? There are not integers, they are really different dimensions that need to be accounted for. Okay, so, and we do the same for marital status, basically all the categorical variables. Okay, it's good practice to do that. Okay, so once we've done that, well, we still have the same number of lines, but we have many more columns because of all those extra categories. Okay, so if you're a little bit new to machine learning, this might sound like, wow, this is insanely complicated. I'm already lost. So don't worry, there's hope. But yes, I have to say it is a little bit complicated, and this is why you need machine learning engineers and data scientists. Okay, but I'll show you a much simpler solution in a few minutes. Okay, I just want to show you the hard one first. Okay, next we need to split the data set. Again, it's good practice to split your data set into training. So for training algo, validation to evaluate model accuracy during training, and testing, which you'll use only at the end of the training process. Okay, so we split that data set 3 ways, and we save 3 CSV files, which we see here. Okay, AutoML, test, train, and validation. Okay, AutoML is for later. Okay, test train validation. I upload those 3 files to S3, okay, because that's where SageMaker needs them. I define their location in a Python dictionary, okay, and then I'm done. All right. So that's the pre-processing step, and you can see it is a little bit awkward, and it's a little bit, it sounds like black magic in a way. And I guess it is black magic. You definitely need a bit of experience to know what to do here. And this is why machine learning is not easy, especially if you're new to it. So we'll see how to solve that with AutoML in a few minutes. Okay. Now let's train the model. So the data set is in S3, and now we can just say, hey, I want to use the XGBoost algo because I know it's going to work. I know it's a good algo. It's a good general purpose algo for different things and specifically for classification. So I can just use the XGBoost built-in algo from SageMaker, and I use the latest version here. And then I'm going to configure this really important object from the SageMaker SDK, right, which I imported here. And it's called the estimator. And this is the object that lets me configure a training job. So it's a little packed, okay, because I want to show you here some of those new capabilities. So let's start, top to bottom. So first, of course, the container, the algo I want to use, which is XGBoost, permissions, because SageMaker needs permissions to access your S3 bucket, and a few more things. How to access the data. So basically use file mode, which means copy the data set to the training infrastructure. There's another way called pipe mode where you would stream it, but here it's a very tiny data set, so I just can copy it and just get it done. This is where I save the model. Okay, these are my training infrastructure requirements. I want to train on one M4 2XL instance. Okay, so far so good. If you worked with SageMaker before, you've probably done this before. And well, here's the new stuff. Well, as of a few months ago, we can use spot instances, and which are really similar to EC2 spot instances if you've worked with those. So basically, unused capacity that we can grab at a very deep discount. We'll see what kind of discount we get here. And then I'm going to configure debugging. Okay, so this is one of the newer capabilities. So let's slow down a bit because I need to explain. So SageMaker debugger is going to, while the training job is running, okay, it's going to try to inspect what's going on. Okay, so it's going to look at the internal state of the model. So all the training parameters that are being learned, okay, and these are called tensors. Okay, tensors is just a fancy word for multi-dimensional array, and but that's what they're called, tensors. So all that internal state is going to be saved to S3. Okay, and this is what we see here. So the output path. Okay, so save the training tensors, the internal state of the model, to this S3 location. And these are the tensors I want to save. We have different collections. So I want to save metrics, accuracy, etc., etc. And I want to save feature importance. Okay, and we have different collections that are available. And just say, hey, save that stuff, and debugger knows what to do, right? And this works for built-in algos, and this works for the built-in frameworks, TensorFlow, etc., etc. Okay. So what do we do with that data that we saved in S3? Well, it's going to be there for you to inspect, as we will see. But we can also ask debugger to say, hey, can you check for this rule? Okay, and here I want to check for class imbalance. And this is one of the built-in rules in debugger where, again, looking at the tensors that we save in S3, we're applying a predefined rule looking at, well, basically, is this model seriously impacted, bothered by a class imbalance problem? Does it mispredict heavily because of class imbalance. So here I'm using default parameters to keep it simple, but you can actually tune that and say, well, if you mispredict that much, then trigger the rule. Okay. See, this is just one of the built-in rules. There are many more, and you can write your own custom rules. Okay, so keep in mind these rules will be applied while the training job is running on the tensors that have been saved here. Okay, and it all happens automatically. The only thing you need to do is this, right? Okay, moving on. So we need to set some hyperparameters, so training parameters. And here we are training a binary classification model. And I want to use the area under curve metric for this. And we're good to go. So I can call fit, passing the location of the training set and the validation set. And we see the training job starting, right? And again, if you've used SageMaker before, you see the usual log. And well, this is kind of new, right? We see something new here. We see that debugger job starting in parallel, okay, of the training job. And now we know how this works. The training job is saving tensors to S3, and the debugger job is inspecting those tensors in parallel, checking for the rules you configured. Okay, so in this case, just one rule, class imbalance. If I'd configured multiple rules, then I would see multiple outputs corresponding to multiple debugger jobs running and inspecting for a specific rule. Okay, well, the rest is, I would say, SageMaker as usual. We copy the data to the training instance, and we see XJBoost output. Let's skip that stuff, and we see that after 74 seconds, we were done, right? And look at that. Well, that's my favorite part, right? I'm only billed 15 seconds instead of 74 because I used a spot instance, and I can enjoy that very sweet 79.7% discount. So these two lines that we configured in the estimator, right? They saved us 80%. So I think you want to read about that, right? Make sure you use that stuff. It can make a big difference if you're training, day in, day out, 19 night out maybe, right? Spot instances on SageMaker. Okay, so the model was saved, the tensors were saved, and what about our debugger job? Okay, so we can see, so I run this notebook in sequence. So I think when I run this cell, the debugging job was not quite over, and it still says in progress. But if I run it again, all right, it says no issues found. Okay, so that's great news. It means exactly what it means. It means that class imbalance rule was not triggered. So whatever threshold we set, was not met. Okay, so that's all right. And now we can still want to, we want to look at those tensors. So we can use the SageMaker Debugger SDK and say, well, just give me the path where those tensors were saved, and please create a trial from that. Okay, and then I have access to the different collections of tensors, and I can use different code to display it. So here it's just a little bit of a matplotlib code that I think I stole from another notebook. Okay, and I can plot the metrics. Okay, I can just I can just use that stuff, and I can look at all kinds of different things here. All right, so I could look at all the tensors that are saved, and I could view all those values. And if that rule, if that class imbalance rule had been triggered, of course we could zoom in on that internal state of the model, and hopefully understand what's going wrong here. Okay? And of course you have to understand how the algo works. But if you know what you're doing, if you're familiar with the algo and the model, then you can quickly figure it out. Okay, so this is pretty cool. And well, the last bit, I guess, is just deploying the model. So SageMaker makes it very easy. Just call xjboost xjb.deploy. Okay, again in the SageMaker SDK. If you've used SageMaker before, you're used to this, right? Endpoint name, initial instance count, instance type. But maybe this is new to you, right? The data capture config. So this is the SageMaker model monitor configuration. And what I'm saying here, I'm sure you can guess, it means, hey, please capture data sent to this endpoint, capture 100% of it. I think default is 20%, if I recall correctly. So capture everything and capture incoming data and outgoing data. So basically data and predictions. Again, that's the default value, and store that stuff in S3 as always, okay, at this location. So now, once the endpoint is up, everything that is sent to the endpoint and all the predictions that are returned by the endpoint are going to be captured. Okay. So of course I need to send some data to the endpoint. So here I'm using the 100 first samples from my test set. Okay. So basically the 100 lines of CSV with just the features, of course, not the label. And I invoke my endpoint and I read the answers. Okay. So I see probabilities between 0 and 1 because this is a binary classification model. But more importantly, let's keep moving down here. If I list that capture path in S3, well, I will see some files, right? Storing, hopefully, the input data and the predictions, all right? And well, if I copy them locally, right? And if I open one of them, I can see the input and output, right? So here's the input, and we see the features here, okay, encoded in CSV, and I can see the output here, and this is the probability between 0 and 1 that this specific customer will accept the offer. So it's very low, so we can count this one as a 0, okay? And so this is model monitor. And this is very valuable because you could use it to capture real live data that you want to replay on your dev and test endpoints. So that's already very useful. So the next step would be to train a baseline using the training set, okay, and then ask model monitor to compare the live data to the baseline, right? And that's the data quality part where you would look for missing features or data drift, statistical differences between live data and training data, right? Which would mess with the way your model predicts. Okay, so I'm you know, for an interest of time, I can't show you all of it, but you'll find plenty of sample notebooks in the SageMaker examples repository on GitHub, and I'll give you the URL at the end. Okay, just want to give you a quick tour of those different things and show you how easy it is to set that stuff up, right? Even if you're just using the SDK, we haven't used Release Studio yet, right? If you use the SDK, you just do this and you're good, right? All right. Of course, we could try batch prediction as well. Okay, create a transformer and batch predict the test set. This is not different from how it was happening before. We can grab predictions from the batch job in S3, and once we're done, we could delete the endpoint. Okay. So we already in this notebook we saw we quickly saw how to use debugger and model monitor. Okay, so let me show you more. So now there's always more, as you know. So now using the same data set, okay, let's say we want to do model tuning, right? So let's say we want to automatically figure out the best hyperparameters for that job. So this data set preparation steps are exactly the same. The estimator is exactly the same, right? And I'm still using Spot, as you can see. So I did not configure debugger. the debugger job here, but same estimator. And then I say, hey, why don't you go and explore those 4 hyperparameters for XGBoost? And they're a little bit crazy, and mean child weight and max depth and alpha and all that good stuff. So let's not look at those in detail. You can read about them in the XGBoost documentation. But these are important parameters in getting good accuracy with XGBoost, and we want to explore those different ranges, right? And we want to maximize the area under curve metric, which is a good metric for classifiers. Okay, and we create our hyperparameter tuner object with the estimator, the metric, the ranges, and how many jobs we want to run. So here I'm running 40 jobs, exploring 40 different combinations for those hyperparameters, and I'm going to run them 4 by 4 with those spot instances. Okay, I can call fit, gets everything going, and after a little while, okay, I want to look at this, those results. So sure, I could go to the SageMaker console and I would see those different jobs, but I could use the experiments SDK here once again. So I could say, hey, I want to look at those different jobs. So please create this job analytics object, okay, from the SageMaker SDK. Return everything in a pandas data frame, okay, Swiss Army knife again, and I can see all my jobs, right? And I can just look at that stuff and see, well, okay, 40 jobs. These are probably not sorted. I can see the metric here. Okay, so that's the area under curve, 0.95, and different values corresponding to the different hyperparameters that were tried out. Okay, yeah, I can see them here. Okay, so I've got those 40 jobs here. So that's not super easy to look at. And I want to say, maybe I just want the top one, right? So give me the best job. So take that pandas data frame and just sort it by descending metric. Okay, so and show me just the first one. So the top one is 0.95, 1031, right? And that's the top job that I get. Okay, so that analytics SDK makes it very, very easy. Even if you had 1,000 jobs that had been run in that tuning job, you can very quickly find out the ones that you want. And this is standard pandas, and again, it makes it easy to sort and filter and find everything that you need. Let's say I want to deploy that job. Okay, so business as usual, just call deploy, right? And yeah, I still got a good discount on that training job, so that's fine. And after a few minutes, the endpoint is up. And again, I can predict, just like I've done before, okay, get some results. And when I'm done, I can delete it, okay? So again, this is just really a flyover, a whirlwind tour of the SageMaker SDK. But that's still a lot of code, right? So, and I promised I would show you how to do it really, really simply. So how do we do that simply? So let's reboot that demo, okay? So let's say I have this data set and I want to build that classifier, okay? I want to build that binary classifier. So what do I need to do? So of course I need to download the data set, okay, which we've done before. I can take a look at it, all right? And you can see I'm not cheating, it's the exact same one, okay? And this is the initial data set, it's not processed, okay? I haven't done any of those crazy data science things. Okay, so here I just split it. So this is not mandatory. This is just really for me. I'm keeping 5% of the data set on the side, which I'm not going to pass to the training job because I want to be able to score the model with the data that hasn't been used at all for training. But I could pass the full data set. Okay, so I'm just splitting in two this time. So AutoML.train, AutoML.test. Upload the training set to S3, And then, well, where's the rest? Okay, so the rest, my friends, is here. Okay, so that little flask here means experiment. Okay, and this is where you can go and browse the different jobs that have been run, but you have this nice little button here called Create Experiment. Okay, and well, let's just click on it. And let's read, right? Create Amazon SageMaker Autopilot Experiment. Well, that sounds very nice. And this is the AutoML capability I was referring to. So what would you need to do? You would need to give it a name, okay? You would need to pass the location of the data in S3, and well, we have that, okay? Basically just do this, right? Okay, let me do it. Let me show you how to do this, okay? All right, demo. All right, so just put the location of that CSV file. Remember, this is not processed, okay? I haven't changed anything. The target attribute name, okay, so this is the column you want to predict, okay? So remember, let's just go here. That column is called Y, okay? The label here. So just say, okay, Y. And output data, well, we could just store output data in output. How about that? Okay, so where's the data set? What's the thing you want to predict in the data set? And where do we store results, right? Anyone can do that. And then select the machine learning problem you want to solve. So of course you could say, well, it's a binary classification problem because I know that's what it is, and I could pick a metric for it. Or it could be a regression problem, and I would just pick it. Or I could just be lazy, right? And laziness is a virtue here. Let's just say auto. You figure it out, right? This is supposed to be clever. So go and figure out what this problem is, okay? And yes, I want to run a complete experiment, okay? And we'll see what that means in a second. Click on that button and off it goes. And the reason why I'm not clicking on the button is that it is going to run for a few hours. And of course, I've done this before, and we can look at results, okay? And so what you will see, okay, you will see a lot of fancy graphics happening for a while, and you're going to see the autopilot job go through different steps. Okay, so the first step is data analysis. It's inspecting the data set. It's figuring out what kind of problem you're trying to solve, etc., running basic statistics. Okay, then it goes to the feature engineering step, where it's going to transform the data set automatically for you. Okay, remember those slightly unpleasant steps we had to do in the first notebook, selecting features, etc. Well, these are taken care of automatically here. All right, and then it generates notebooks. Okay, so let me try to open that guy here, and this notebook is going to show you everything that the autopilot job is considering. So what are the candidates? What are the combination of algos that are going to be tried out on that data set? Okay, so so we see transformation jobs, and we see XGBoost being used here. Okay, so we see those DPP1 and DPP2, right? And we have the description here. Okay, so a combination of data transformation and training. Okay, and you can click on all those things and learn more. So we call it transparent AutoML or white box AutoML, because we're not just training something and dump it on you and say, hey, here's the model, right? And trust us, it's good. We train the model, but we also tell you how we're doing it and what we considered in training that model. Okay, so you can actually run that notebook. It is a proper notebook. It's not just documentation. You can run those steps yourself, and you can keep tweaking, right? You see hints here on how to tweak, and this is available when the feature engineering step is complete. And then it's going to build the different data sets based on that. Okay, so it's going to run those 10 pre-processing steps to generate the 10 transform data sets, and then it launches a monster hyperparameter tuning job. Okay, which is similar to the one we run here, right? But tuning many more parameters and basically, being more clever than we could ever hope to be. And by default, it's going to run, I think it's 500 different jobs. Okay, so that's why it takes a bit. And of course, you can change this value if you want, but by default, it is going to run for a few hours. All right, and then of course we see all those different results. Okay, so sure, we could do this and say, well, give me the top one. So the top one seems to be this one, with 0.9193 metric, and we could click on deploy and do this manually. Okay. Or we could say, well, I want to know maybe a little more. So we could look at each one of those different models individually, and we could look at them in detail, see exactly what happened here. There's tons of information here, right? Look at the pre-processing jobs, etc., etc. Or we could say, well, who wants to search through 500 jobs, right? So, no one wants to do that. So we could open that AutoML job here. And we could say, well, I'm interested in training jobs specifically. Okay. And I can sort them here, maybe. Right. So here I selected the top 10 models, and I can chart them. So I can add a chart, click on this, and so as you can see, these are really short training jobs. So if we look at time series here, we're not going to see much. But if you have, long-lasting training jobs, time series will show you all kinds of things. So maybe we could just look at our scatter plot, and maybe we want to. Okay, let's try maybe to plot some hyperparameters. Not sure what we'll see here, but come on, let's give it a try. Okay. All right, so we can see, right? So we can see alpha, the influence of alpha versus gamma, and so that can tell you, right? You can visualize pretty much all the, as you can see here, it's quite extensive, all the metrics and the hyperparameters. So you can zoom in, really you can drill down and visualize all kinds of metrics on your models. Okay, and if you're interested in this guy, well, okay, this is it, right? Okay, this is the tuning job, and you can find it in this list here. Okay, so really easy visualization that helps you compare those different models and compare experiments, etc., etc. Okay, so yeah, we could play with that stuff all day long. So there you go, right? And well, did we write a line of code, honestly? So sure, okay, I wrote a few lines of code to grab the data set and upload it to S3. But assuming the data is in S3, everything else was just click on create experiment, and then open the experiment and look at the models, right? And you could deploy. Models again, clicking on just clicking on those items here, and I think we see the endpoints. I have a couple of endpoints live here. Okay, and I could enable monitoring as well. Okay, so that data capture that I showed you before is pretty much built in for you here. And this shows you how to do the baselining and comparing the training set with the live data, etc., etc. So again, this is still in preview, so expect some of that stuff to change over time, but this is really the direction we're going, right? Put everything in the same place and try to make it simple for you to experiment and build and train and deploy and use those advanced capabilities in the same tool, in the same environment. Okay. All right. I think we're almost done, and I just want to share some resources here. So these are some links I recommend. Of course, you can look at the free tier. SageMaker is part of the free tier, and you can really experiment at a tiny scale if you want. Of course, if you start training, and especially if you start playing with SageMaker Autopilot, this won't be in the free tier. Okay, so just make sure you understand pricing before you fire up those hundreds of jobs. The second URL, of course, is the SageMaker service, and you'll find feature descriptions and customer stories and everything else. The next two URLs are the SageMaker SDK, okay, which I used in those notebooks. And the SageMaker examples is that repository where you'll find really a ton of notebooks showing you how to use SageMaker in pretty much every configuration, built-in algos, built-in frameworks, bring your own container, monitoring, debugging, spot instances. I mean, it's growing all the time, and I cannot recommend them enough. And a couple of links on my own. So my YouTube channel, where you'll find quite a few extra videos on SageMaker, highlighting different features, going through demos and how-tos, and you may like that. And my blog on Medium, where you'll find technical posts and also my podcast on machine learning. Okay. So I think that's it for today. I hope you learned a few things, and I hope you are excited about SageMaker Studio and SageMaker Debugger and SageMaker Model Monitor and all the other ones. It's a growing family, and we're trying to make your machine learning workflows as simple as possible. So please send us feedback. You can go to the AWS forums or go through your AWS contacts, or you can ping me on Twitter or anywhere you find me, and let me know how you're doing. Okay. Thank you very much for listening, and I'll see you soon. Bye-bye.